Let's use some trig identities. If tangent theta is negative 5/3 and theta is in quadrant 2, find the function value. And the first one we want to find is secant theta. Well, a trig identity involving tangent and secant is the identity tan squared of theta plus 1 is secant squared of theta. I want secant, I know tangent. Tangent is negative 5/3. Keep in mind the quadrant 2 part, and we'll use that shortly. We're going to put negative 5/3 and square it for tangent squared, and add 1, and we'll get secant squared of theta. And we're looking for secant of theta. Squaring negative 5/3, we get 25/9 plus 1 is secant squared. 1 is the same as 9/9. 9/9 plus 25/9 is 34/9. And if I take the square root of both sides, I get plus or minus the square root of 34 over the square root of 9, which is 3, is secant theta. Now there's two values here, but if theta is in quadrant 2, I know secant theta is going to be positive, and so the result I'm looking at, not positive, I'm sorry, negative in quadrant 2. And so secant theta is negative square root 34 over 3. Well, let's continue this example. And again, given tangent theta is negative 5/3 theta in quadrant 2, we want to find sine of theta. Now, there's a number of ways to find sine of theta using tangent. One way is to use the fact that tangent of theta is sine of theta over cosine theta. And I just came up with secant of theta being equal to negative square root 34 over 3. I just found that. The secant is the reciprocal of the cosine, or the cosine is the reciprocal of the secant. Let me put the reciprocal of this for cosine, and for tangent, put negative 5/3. So negative 5/3 is sine theta over cosine, which is going to be negative 3, divided by the square root of 34. And I'm going to solve for sine by multiplying by the fraction negative 3 over square root 34. So I'll have negative 3 over square root 34 times negative 5 over 3 is sine theta. The negatives will multiply to give me positive. The 3's will simplify, and I have 5 over square root 34 is sine theta. And if I rationalize the denominator, I end up with sine of theta being 5 square roots of 34 over 34. To get to that result, I multiplied the numerator and denominator here by the square root of 34. And I found the sine of theta. Let's do one more part for this example. Again, here's what we're given. Tangent theta is negative 5/3. Theta is in quadrant 2. We want to find the cotangent of negative theta. Well, the cotangent is related to the tangent in that they are reciprocals. So the cotangent of negative theta is going to be the reciprocal of the tangent of negative theta. Remember that the tangent of negative theta is negative the tangent of theta, and now I can put negative 5/3 for tangent theta and write 1 over negative 5/3. That's 1 over 5/3, which if I multiply by the reciprocal is 3/5. So the cotangent of negative theta is 3/5. Let's work with some trig identities. We want to express cosine x in terms of tangent x. There's a number of different identities we could work with, but let's work with tan squared x plus 1 is secant squared x. Now there isn't a cosine involved, but secant, or the reciprocal of secant, is cosine. So what I'm going to do is take the reciprocal of each side of this equation, which will give me 1 over tan squared x plus 1 is 1 over secant squared x. Then 1 over secant squared, since I'm trying to get cosine involved here, 1 over secant squared, I'm going to write as cosine squared. So I do have cosine and tangent involved in this equation, in this identity, but what I want is just cosine, not cosine squared. So I'm going to take the square root of each side using plus or minus. So plus or minus 1 over, the square root actually, of 1 over tan squared plus 1 is cosine x. And I should probably go ahead and rationalize this denominator. The square root of 1 is 1, and so it is 1 over square root tan squared x plus 1. To rationalize the denominator, multiply the numerator and denominator by square root of tan squared x plus 1. And then simplifying, we can say that cosine is plus or minus the square root of tan squared x plus 1 over tan squared x plus 1. And we have cosine in terms of tangent. And with cosine in terms of tangent and the plus or minus, recall that the quadrant that x is in would determine whether to use plus or minus when using that identity.
Right. 1 plus cotangent squared theta divided by 1 minus cosecant squared theta in terms of sine theta and cosine theta, and then simplify the expression so that no quotients appear. What I've done is rewritten that original expression on a sheet so that we'd have enough room to complete it. Let's take a look. So 1 plus cotangent squared theta, we can change cotangent squared theta into cosine squared theta divided by sine squared theta. So let's begin with that. So this would be equal to 1 plus cosine squared theta divided by sine squared theta. Then cosecant squared theta we can write as 1 over sine squared theta. So this would be 1 minus 1 over sine squared theta. Next, what we can do is multiply both the top and the bottom by sine squared theta. And so when we do this, of course, we must distribute this into the parentheses. So 1 times sine squared theta gives us sine squared theta. When we multiply sine squared theta times this quotient, we can remove a factor of 1. The sine squared theta divided by the sine squared theta is equal to 1, so we have plus cosine squared theta. Divided by. Next, we distribute the sine squared theta into this parenthesis, so sine squared theta times 1 is sine squared theta. Then we have minus. When we multiply here, we get sine squared theta divided by sine squared theta, which is 1, times the 1 that's in the numerator, so that's equal to 1. Continuing along, we know that sine squared theta plus cosine squared theta is equal to 1. So in our numerator, we have 1. Sine squared theta minus 1 is equal to negative cosine squared theta. So in the denominator, we have negative cosine squared theta. And then finally, this would be equal to, with the negative out in front, we look at just 1 over cosine squared theta. That is equal to secant squared theta. So it's negative secant squared theta. So our original expression, 1 plus cotangent squared theta divided by 1 minus cosecant squared theta, is equal to negative secant squared theta.